If you would open to page 3 in your packet, I'm on number 2. Make sure that you're taking notes in your packet. And if I look at this one, I need to solve for x. It says to the nearest tenth, so yay, we get to use calculator for the first time. But notice that what I'm looking for, x, is actually an exponent. So I have to somehow remove all of this junk here and to get that exponent by itself. So the easiest thing I think to probably do first, now please understand that this is not 2 times 4, so this is not 8 to the x over 3 power. 4 is the thing that's raised to the x over 3 power. So the 2 is not attached to that. It would have to be in parentheses with it, which it's not. So let's just go ahead and let's divide that 2 out first, which isn't going to leave us with something pretty, by the way, but that's all right. That's why we have calculators. So that's going to be 23 over 2, which does not divide evenly. I'm just going to leave it because I've got a calculator, so we'll worry about it later. All right. You also learned this in Algebra 2. It might have been during the shutdown, so who remembers anything, right? And here's the deal. We want to find x, but x is an exponent. We can de-exponent this, so to speak. And I don't know if you remember, your log rule says that if you have an exponent, you can drop that exponent down in front as long as you log this base and log this base. So I'm going to repeat that one more time. We can take this exponent and drop it down in front as long as we log both your bases. All right. So I'm going to circle this, and I'm going to draw an arrow. And I suggest you do the same thing in your notes because I think it's a good way to remember it. So that x over 3 comes down, and then, like I said, we log 4. Okay, so the opposite of an exponent, or the inverse of an exponent, is a log. And you learned that last year. So that's why we're logging that base. But what you do to one side, just like anything, you have to do to the other side. So that's going to be the log of that base, which is 23 over 2. Okay, don't worry about the log. That's what we have a calculator for. So I'm going to try to get that x by itself some more. So I'm going to divide the log 4, which will cross this out. And I'm going to divide it over here. And I know that I don't know what that is, but it doesn't matter because I have a calculator. And so we've got an ugly mess of log of 23 over 2 divided by the log of 4. Okay, well, now let's look at the only thing left that's attached to that x is the divide by 3. So how do we get rid of a division of 3? Hopefully you know that that means we would multiply by 3, which would cancel that out. And then we're going to multiply this by 3. And then we can throw that whole big ugly mess into our calculator. All right, so let me show you what that looks like. Okay, so look at how I typed that in. When I would type it in exactly as you see it here, the only thing is I would put the 3 in front. So I have a 3. Then I've got this parentheses, so I put in that parentheses. Then I do alpha y equals to get a fraction. Okay, the alpha button is on the left-hand side of your calculator. They're up toward the top above math. And then you hit y equals, which is in the top left-hand corner, and hit enter. And then it'll give you a fraction. And then I just typed in log. It opened up a parentheses. Remember, the log button is on the left-hand side, just to the left of the 7. Then I did alpha y equals again, plug that in, and divided by log 4. Came out of that fraction, close the parentheses, there's your answer. And if you read the question, it says specifically to round your answers to the nearest tenth. So your final answer is going to be x equals 5.3. Okay, now let me also just talk up for a second. The reason why we logged these 2 bases here is because we needed to get this exponent down in front. Okay, so when we just have our bases, and our bases are numbers like 4 or a fraction, we log both those bases. When we get to number 4, which we're going to do in a second, I see an E there. And you should remember from last year that when we have an E, we don't log, we ln, which is a natural log, as they could say. So what I mean by that is, let's look at number 4. So you see that you've got an E there. So we are, instead of logging, we're going to end up lnning. And let's just take one step at a time here. So the first thing I'd probably do is get rid of that negative 16, or that positive 16 by subtracting 16, sorry. And we're going to get 35 e to the 0.2x power. Notice my exponent has the variable that I'm looking for, so I know I'm going to have to log or ln. And over here, I'm obviously just going to get 12. I would get rid of that 35 by dividing it, since it's being multiplied right now. And that's going to give me e to the 0.2x equals 12 over 35. Don't worry about making that a decimal, just leave it. It's more accurate if you leave it and don't make it a decimal and round stuff when you're not supposed to round. Okay, this is what I'm talking about. So we need to get this exponent down, just like we did on the last question. But the difference is here is our base is not a number, it's e, and e is a special kind of number. So if you remember from last year, we can still take this and put it in front, like we did with number 2, but instead of writing log, we write ln. All right, so I like to just circle this and tell my brain that that's got to come down in front, and that's going to give me 0.2x. Then I ln that base equals, and then I ln the other base, 12 over 35. Okay, you should hopefully remember that the ln of e is really just a 1. And you could put that in your calculator to check it if you don't believe me, but take my word for it, the ln of e is 1. So really then all you're left with over here is 0.2x equals the ln of 12 over 35. Please make sure you're writing this in your notes. Then we're just going to divide that 0.2, okay? And then we're going to throw it in our calculator. Alpha y equals, go for it, pause me, get an answer. Remember the ln button is down the left-hand side of your calculator to the left of the number 4. And I have negative 5.3522. And they want this to the nearest tenth, so that's going to be negative 5.4. Okay, so if you turn the page and look at page 4, we've got some log rules up at the top there. Again, you did all of this in Algebra 2, but I don't know how much you remember, so it's always good to review. So if you look at 1 and 2, and we're going to take notes in our packet with this, if you look at 1 and 2, you may have learned this phrase called circle the base, run the race, or I shouldn't say may. You should have learned circle the base, run the race. So we circle the base, which is our subscript, which is a 3, and we run the race. So we go to the other side of the equal sign. The equal sign is like the finish line. Okay, when you cross the finish line, right, you break the tape if you're in first place. So we cross over the equal sign and have our arrow go to the number on the other side of the equal sign. All right, so this is what that circle the base runs the race. So let me write that down. So and you should as well. Circle the base and run the race. Okay. So what that means is we can get rid of that log that's in the equation. And what we do then, by circling the base, run the race, we can drop down that 9x plus 2 equals, and then our base is the 3, and run the race is the exponent. And look at what we did. We just took an equation that was a logarithmic equation, has a log in it, and we turned it into an exponential equation, which makes it easier for us to solve for x. Okay, so then all we have to do now is work it out. So we've got 9x plus 2. 3 to the 4th is 81. Let's subtract that 2 over. And we have 9x equals, what, 79? Oh, that's not pretty. And then we just divide it by 9. So we have x equals 79 over 9. Now, listen, directions don't tell you what you should round to or anything, so if it doesn't say, I would always leave it as a fraction. Okay, so number 2 is similar to number 1, but the difference here, if you look at this one, this had just one term involving a log. This one has 2 terms. So don't panic, it's really not that much more difficult. Here's the thing, is that these 2 terms are separated by a plus sign. So we do what we call product rule. So if we look up here, do you see there's a plus sign between 2 log terms? And what that basically means is we can condense this side and turn it into multiplication. So addition with the log equations means we can change to multiplication. Subtraction with log equations means we change to division. Okay? All right, so let's try to condense. So when I say condense, all we do is we're going to take this left side and we're just going to write it with 1 log base 4. And then I'm going to open up a set of parentheses and I'm going to take this first term here, which is the x, and since it's addition, I am going to multiply it by this second term here, which is x minus 12. And I'm just going to keep that equals 3 for right now. All right, well, let me just simplify that just a little bit. So that's log base 4. And that is going to be x squared minus 12x equals 3. So now, if you look at what I have right here, I have one term on the left-hand side of the equation that has a log base. Just like I did here, I had one term on the left-hand side of the equal sign that had a log base. So this is very similar to this now. And what did we do here? We circled the base, ran the race. Now we're doing that because look, there's no log base over here. There is over here, but there isn't one over here. So when we have kind of like an unbalanced equation, in other words, only a log base on one side and not on the other, that's when we do this circle the base, run the race. Very important. I'll say it one more time. When you have an equation and it's kind of unbalanced in the sense that the left side has a log base 4, but the right side does not, that's when we do circle the base, run the race. So let's go ahead and we're going to circle the base, and remember, run the race, we always cross the equal sign. And what this does is it just gets your equation out of log form. So now I can just write this as x squared minus 12x, and when I say circle the base, that base is always going to be the base, and run the race will be your exponent. So the arrow goes to the 3, so that makes that your exponent. Okay? All right, now we're just going to work this out. So I have x squared minus 12x equals 64. All right, well, I have a quadratic, so I'm going to bring that 64 over, and that will give me minus 64 equals 0. Okay, and then I can factor that, and that's going to be x minus 16 and x plus 4 equals 0, which is then going to give me x equals 16 and x equals negative 4. Okay, now the only thing that you have to be careful of when you have two answers, or really any answer, so we really should have looked at it with this one as well, but let's just stick with this one right now. If I plug a 16 back in here, do you see that obviously this is log base 4 of a positive number? 16 is a positive number, right? If I put this 16 right there. Now, let's put 16 in here. Does this also stay positive? And yes, it does. Here's the problem. If either one of these, it doesn't matter which one, this one or both, are negative, you can't have a log of a negative number. Try it in your calculator. Take the log of a negative number. Okay, and if you do that, I'm doing it as I speak right now, I get error, non-real answer. So we can never have a log of a negative number. So let's look at -4. Do you see that if I put a -4 in here, that's a negative number? So we're going to have to reject that answer. Also, if I were to put -4 here, that would give me -16. Okay, so it doesn't work there either. But it only has to not work in one spot, okay? But it happens to not work in two. So your final answer is x equals 16. Alrighty, so I'm on to number 4, actually. I am going to skip number 3. I'm going to save the best for last. Now, number 4 is just like what we did on number 1 and 2, in the sense that you have an unbalanced, so to speak, equation. You've got a log on the left, but you don't on the right. So that's where we're going to be doing circle the base, run the race. But notice we don't have a base here. So if there's no base, you know how like if you had, if you wrote x, we really know that that's 1x, but we don't always write the 1. If there is no base, like there isn't a base, a subscript here, then we always assume that that subscript is a 10. So that's log base 10, okay? Because that way, now again, I'm going to repeat that one more time. Anytime there is no subscript, there is no base, we always assume it's a 10. Just like up here, if we just had an x, we always assume there's a 1 in front. Okay, so we're going to circle the base, run the race. So circle the base, run the race, and this gets it out of log form. Okay, so then we just have 5x minus 10 equals, the base is 10, the x1 is 2. So that's really 100, right? So we have 5x minus 10 equals 100. Let's add that 10 over, so that's going to be 110. And then we're going to divide out that 5, and we get x equals 22. And there is your answer. Now let's just double check, because we don't want a negative. Let's put this 22 in here, and do you see if I put 22 in here, that's going to be 110 minus 10. That's a positive number. I don't care what the number is. As long as I know that it's positive, we're good to go. So final answer, x equals 22. Now, let's look at number 3, because this is fun. Notice we have a balanced equation. We've got a log on the left, a log on the right, and another log on the right. So this actually makes your life so much easier. When you have logs everywhere, guess what you can do? Bing, bing, bing. But that only works if you have logs everywhere on both sides of the equal sign. Now, I'm not going to be doing number 6 on page 4, but look at number 6 on page 4. It's got log base 6 on every single term. So you could cross out all those log base 6s. Okay, you cannot do it in number 5 because the 3 on the right-hand side of the equal sign doesn't have a log base 2. Now, yes, we can cancel everything out, but we just have to do one little thing, and it's a little thing, so don't whine. It's not a big deal. So we're just going to write 2x plus 1 equals, and here we go. See how we have a minus sign? Remember what I talked about on that last question. Minus sign means division. So all you're going to do is you're going to write this term divided by this term. So watch. So you're going to write 2x plus 2 divided by 3. So you're applying the quotient rule. When you see subtraction with logs, you divide. Now, don't panic on this one because I'm just going to put that thing over 1 and cross multiply. So that's going to give me 3 times 2x plus 1 equals 2x plus 2. Now I just have to solve. So that's going to give me 6x plus 3 equals 2x plus 2. Bring the 2x over, so that's going to give me 4x plus 3 equals 2. And then I'm going to bring that 3 over, which is going to give me, let me see if I minus 3, right? So that's going to give me negative 1. And then I'm going to divide out that 4. So x is equal to negative 1/4. Okay. Now, again, we do want to double check and make sure that negative 1/4 doesn't make this or this, well, there is no x here, so this or this, it doesn't make it negative. You can do this in your calculator. If you do 2 times negative 1/4, you're going to get negative 1/2 or negative 0.5. Plus this, that's positive. Okay, 2 times negative 1/4, again, negative 1/2, plus 2, positive. So we're good to go. There's your answers.